Today I wanted to show you how the sleep mode of any Cortex-M processor core is entered. Every manufacturer has his own exact implementations for how sleep and standby modes are entered, but there is only one useful call to stop the core of any Cortex-M processor, and that's the same for any manufacturer. The WFI instruction. WFI stands for wait for interrupt. I can already hear some of you scream, but there's also WFE. What about that? In my opinion, WFE wakes up the core too much. WFI gives an exact moment of when the core will wake up. Most of the processor clocks are powered by two sources, mostly external crystals. Each manufacturer has slightly different names for them. NXP, for example, calls them the main and RTC oscillators. Nordic calls them the high and low frequency oscillators, the HFXO and LFXO. And ST, for example, calls them the high and low speed clocks, the HSE and the LSE. The ARM core is capable of shutting down the high speed clocks, the high frequency clocks in these examples. The low frequency clocks are used to power the real-time clocks and are not touched by the core shutting down. What I have here is a PCA 10040. It's built by Nordic Semiconductor, which has a Cortex-M4 inside. This development board has, as you can see, 4 buttons, 4 LEDs, and an antenna, PCB antenna for radio connectivity. But we're not going to use that. I'm just going to demonstrate the low power capabilities of the Cortex-M4 core that's available in this processor. And I'm going to do that by making a simple program. When I click this button, an LED goes on, and in between, when no toggling is required, I will put the CPU into sleep mode, which will bring down the current consumption to a couple of microamps. Alright, this is the application I have right now. The program starts up, it does some initialization of the pin interrupt and the LED, and shows over a UART output some debug information that it starts up. And then just wait and do nothing. We go to the sleep function and we wait. That's it. Let me build this and let me program this, and you see here the terminal output I have, and it shows us started. I have some code prepared. I will go through it together with you. So what I have here is I'm going to disable the interrupts, inform us we're going to sleep mode, and then we're going to call a core specific function. This is the WFI function. This is the wait for interrupt function. This is available in the CMSys header file. And what this does, it waits for interrupts. But when an interrupt occurs or becomes pending, and between the disable and enable interrupts can still become pending, so it will act as a NOP instruction and do nothing. After waking up, we show that we woke up and we enable the interrupts, and the interrupt handler is called, and we will be able to toggle the LED. For the board we are using, it just goes to sleep and shuts everything down. For example, the STM32, it does not automatically shut everything down. You need to set the SCB bit. Now, let me show you this. And see, it started up, it entered sleep mode. And as you can see of the current consumption, we are at a very low current consumption right now. What the STM32 also not does is enable the clocks as you had it before. You need to re-enable the clocks at the correct speed as you had before going to sleep, because it will reset to the internal RST oscillator. So this is why I have the disable and enable interrupts here. So you can do some initialization before you go to sleep. You can also do some processing after you go out of sleep and wake up. When you need to do some pre-processing before handling the interrupt, you need to be aware of some interrupt latency. But after enabling interrupts, the interrupt handler will be called and the interrupt will be handled